Hello everyone. So once again, welcome to Next Gen Tech Hub, and here is our first chapter, Introduction to Robotics. So, what is a robot basically? Here you can see a robot. A robot is a programmable, multifunctional manipulator designed to move the materials, parts, tools, or specialized devices through various programmed motions and for the performance of variety of tasks. Tasks, as for examples, you can say assembly, surface polishing, pick and place, and many more. So, what is the difference between a robot and a manipulator? A manipulator is having a fixed base. This is important. A manipulator is having a fixed base, like the robots which are used in the factories or in the in the manufacturing sector, which are also called cobots. That I have told you in the last video, in the first video actually. Like you can see, this is a robot, and this is the fixed base of the robot. Like this is not movable. So, and this kind of robot is called a manipulator. Now, what are the contents of the robot? Like what the robot comprises of? So it is having the mechanical components. It is having the actuators. It is having the transmission devices, sensors, and a computer or a controller, which is called the brain of the robot. This is also called the brain of the robot. Now, what is the what are the mechanical components? Mechanical components, you can say the links and the joints. These are the mechanical components, the structural components of the robot, more specifically structural components. And actuators, if you are an electrical or electronic student, or if you are an engineering student, you should know the meaning of actuators, or something which actuates the motion. So actuators can be electric, actuators can be pneumatic, or it can be hydraulic. So you definitely know what is pneumatic or hydraulic. If you don't know, I will tell you. Pneumatic means the actuator will be operated with the help of air pressure, and if it is hydraulic, then it will be fluid pressure, and if it is electric, then it's the electric charges or the force. And what are the transmission devices? Devices are mainly used to transfer the motion, to transfer the motion. That means, imagine this is a robot. This is the first link, or you can say this link is attached to the base. This is ground. This is ground I have drawn, and this is the link attached to the base, and this is the second link, and this is the third link. So, if the controller if the controller is operating the robot, then how the motion will get transferred to each link and finally to the end effector with the help of transmission devices. Will This will happen, and we will learn more about this in the upcoming sessions. So, what are sensors? So, this is a very common name. Sensors. Everyone know, I think, about sensors. There are a lot of sensors nowadays. Your smartphone is also having sensors. Laptop, everywhere you will get the sensor. In our smartwatches also. Uh, Still, I will explain it. So, sensors it actually helps to sense, and it can be uh, it can be pneumatic sensor, it can be any kind of sensors as per the need. I will tell you in detail later. And lastly, computer or a controller by which we will make the programming. Most of the program are done in teach pendant for ABB robot or Fanuc robot. Sorry, the Fanuc robot teach pendant is for Fanuc robot. So, what are the sensors actually? Sensors actually enable the robot to touch, feel, sense, to touch, feel, and sense. So, sensors helps to touch, feel, sense. Now, you can ask what to feel, what to sense, and what to touch. So, let me tell you the parameters. These are motion. It will sense the motion. Sensors may sense the motion. Sensor may sense the force. Sensor may sense the temperature. May it may sense the humidity of the environment of the space of the robot, and also the heat. Okay, and and the most important function of sensors is that it is used for feedback control. Feedback control. This is the important technical term. Sometimes you may have gone through these questions if you have given the interview for any robotic company like ABB or Fanuc. You may have they may ask this type of questions several times at the function of sensors, and if you say that it helps to touch, feel, sense, okay, that is correct totally, but this is more technical. This is used for feedback control mostly. Okay, so these are the main components of a robot: actuators, transmission devices, sensors, and a controller. Let's get into the next part. Now we will learn what are the classification of robots. So fixed and mobile robot. This I have already told you. Fixed robot means which is fixed, which is fixed, and a mobile robot means it is movable. Like you can say drone is a mobile robot, and other immovable and other movable r- robots like the robots which are having wheels, which are having legs. Humanoid robot, you can say it is a mobile robot, but uh, okay. So now serial robot and parallel robot. So what is a serial robot and a parallel robot? Serial robot means there will be a series of the links, like this is the first link, this is the second link, this is the third link, this is the fourth link, this is the fifth link, this is the sixth link, this is the seventh link. Like this is called a serial robot. And what is a parallel robot? Sorry, PARALL, parallel robot. So let me draw a very basic diagram of a parallel robot. You can see these two parts of the robot are parallel to each other. This is the upper one and this is the lower one. These two parts are parallel to each other. So this kind of robotic structure are called parallel robots. Now I will tell you another point, another important point. Now in this serial robot, there are one joint, two, three, four, five, six, seven. So the degrees of freedom of this robot will be seven. Now, what is it? What is degrees of freedom? If you are a structural engineering student or a mechanical engineering student, you will definitely know about these degrees of freedom. And if you don't know about it, I will explain in the upcoming session or in this session later. Okay. And for a parallel robot, degrees of freedom, it is having uh, multi degrees of freedom joints. In this case, in the case of serial manipulator, degrees of freedom of each joint is equal to 1. Degrees of freedom of each joint is equal to 1. And in this case, degrees of freedom each joint is not equal to 1. Degrees of freedom of each joint is not is equal to 1. That's why uh, these are called multi degree. These parallel manipulators are having multi degrees of freedom joints, and this serial manipulator is having uh, such joints, and these joints are having only 1 degrees of freedom. So this is a basic robotic system. Let me tell you, this is link one. I will write this with different color. This is link 1. Okay, this is link 2. This is link 3. This is link 4. And lastly, this is link 5, or you can say this is the end effector. We don't generally say this is the link 5. We generally say this is the end effector of the robot. Now about the we will study in detail about the links and joints later. So this is joint. This is joint one, because this is also a link. This is this is called link. This base is actually called link zero, and we will get to know about it when we will study the DH matrix of the robot. This is link 0, this is link 1, and this is also a joint J1. This is the joint between link 1 and link 2, so this is J2. This is the joint between link 2 and link 3, so this is J3. And this is the joint between link 3 and link 4, so this is J4. And lastly, there is also another joint in between this end effector and this link 4, and this is called joint 5. So basically you can see from here, uh, this is a type of revolute joint. It can rotate in this manner. Okay, and this link can rotate in this manner. That's why I am uh, writing the theta over here, because it will when the robot will move, it will make an angle. This can rotate like this, or and this can rotate in this way. Okay. Now we will understand what is degrees of freedom. So uh, as we are studying robotics, the multidisciplinary subject, so I will teach you the degrees of freedom in robotics point of view. So for a robot, and just let me tell you the point. Degrees of freedom can be calculated for any mechanical structures. It may be at a single point also. It can be a nut. It can be a bolt. Anything. So if you want to know the basics of degrees of freedom, you can go through the topic called theory of machines, or you can search it in YouTube. Okay. And here I will teach degrees of freedom only from robotics point of view. So for a robot, degrees of freedom is the number of independent movements a robot can make. Imagine this is a planar manipulator. Planar means I have told you before during the classification of the robot while I was teaching the classification of the robot. See, I have drawn only two link manipulator. This is link 1 and this is link 2. And this is the end effector. So let us consider this link 1 only. I am redrawing this part. This is link 1 only. So this is a revolute joint and this is also a revolute joint. So this link can move only in one direction, either in this way or in this way. So it can move only in this plane. It can move only in this plane. So for that reason, this is called a planar manipulator. And similarly, this link 2, can also rotate in this direction or in this direction. So this whole manipulator can rotate in one plane only, this plane. Hmm. Like it can move in this way, it can go in it can move in this way also, either this way or this way. Okay. So uh, let me give you the basics of degrees of freedom. If you don't know the basics, then you will not understand what is it. So let us consider a point, a single point, a single point in 2D, in two dimension. Two dimension means it is having x-axis and y-axis, or any two axes. Let me consider x and y. So you can see from here, this point can go either in this way or in this way, like up and down, and left or right. So it can only move along two straight lines, right? So it is having 2 degrees of freedom. Now, if it is 3D, if I am considering the point in 3 dimension, so it can move either in x-axis, it can move in z-axis, it can move in y-axis. So three translating motion, three translation. Also, it can rotate around x-axis, it can rotate around y-axis, it can rotate around z-axis. Another three rotation, right? So, sorry. 3 rotation. So a point in space, a point in space has a total of 6 degrees of freedom. You can see here 3, 3 plus 3. It is creating trouble here. I don't know why. 3 plus 3. Why 3 plus 3? I have explained here. You may take a note of it. Just pause the video and take the note. Now, let us consider the example of a rigid body in 2D space. A rigid body in 2D. You solve this one and let me know the answer of this one, that what will be the degrees of freedom of a rigid body in 2D in the comment section. I will tell you a rigid body in 3D. Rigid body in 3D. It will be same like the previous one, 6 degrees of freedom. Okay, and the degrees of freedom of planar robot and spatial robot. I have explained you previously that what is a planar robot and what is a spatial robot. Planar robot is having a degrees of freedom of value 3, and spatial robot is having a degrees of freedom of value 6. To to have the to have 3 degrees of freedom for a planar robot, the number of links should be 3, and to have the degrees of freedom of 6 for a spatial robot, the number of links should be 6. Okay. Now, degrees of freedom of a spatial manipulator. Let's get deeper in this section. Let us consider uh, let us consider a manipulator having n number of rigid moving links. That is, number of links is n, and m is equal to number of joints. Okay. Now, the mobility or the degrees of freedom of this spatial robot will be 6n minus summation of I is equal to 1 to m 6 minus ci. Now, what is ci? Where ci is the connectivity of ith joint. Now, what is this actually? Let the number of joints be, let I, let us consider I is equal to 1, 2, 3 till m. M is any number. Then the number of constraints put by the ith joint, then the number of constraints put by ith joint is equal to 6 minus C1. Sorry, 6 minus Ci. Okay. And the total number of constraints, total number of constraints is equal to number of constraints for all the joints. Like for starting from I is equal to 1, the summation of constraints of all the joints. Okay. When we will solve the problems on degrees of freedom, you will get to know about it. You will get a clear idea. So this is the formula for a spatial manipulator. Okay, this is for a spatial manipulator. Now we will study the degrees of freedom of a planar manipulator. Degrees of freedom of planar manipulator. Similarly, I will consider n as the number of links. Okay, m as the number of joints and for the manipulator. Then the constraints put by the number of constraints, by ith joint is equal to 3 minus ci. Why this is 3 minus ci, and why for the previous part it was 6 minus ci, you will get to know about it whenever we will study the problems. And total number of constraints is equal to summation of I is equal to 1 to m 3 minus ci. Therefore, degrees of freedom is equal to 3n, sorry, degrees of freedom is equal to 3n minus I is equal to 1 to m within bracket 3 minus ci. So this is the another formula of degrees of freedom for a planar manipulator. So today I have covered the, you can say, the basics of it also. These are also the basics. So the this is the definition of the robot and what is a manipulator. and what are the constituents of the robot, what are the uses of each constituents. I have discussed this one also, and I have discussed the types of the robot, what is a serial and parallel robot, what is a planar or spatial robot, rigid and flexible robot, fixed and mobile robot. This is a basic robotic system which you can see in the factories. If you are an engineering student and if you have uh, gone for an industrial visit in the manufacturing sectors, then you must have seen this kind of structures in the industries. These are actually called collaborative robots. Okay. Uh, then the degrees of freedom. I know this might be, this might be little critical if you are studying this for the first time, but don't worry, you will be used to with the concepts day by day. Okay, so that's all for today. Thank you so much. Have a nice day.